why do you look so down?
I want to prepare for the NMMS, but I have no idea where to start.
Oh,
Don't worry, I'm here to help. Gory Smart Channel has everything you need for NMMS prep. Just check it out. Subscribe, like, and share.
Really? That's awesome. I'll subscribe to Gowrie Smart Channel right away. Thank you so much.
Hi friends, I am Gauri Shankar. You are watching Gauri Smart Channel. So today we are going to discuss about understanding quadrilaterals. So in the 8th class, this is the most very important chapter because in every exam up to your intermediate level, these quadrilaterals will come with you because these are the most basic concepts today I am going to discuss. So quadrilateral, without quadrilateral we can't do any sum in mathematics. That's what we have to understand the quadrilateral. So first of all, what is quadrilateral and how many types are there and what are they and what are the properties are they? This each and everything we have to understand. So that's understanding the quadrilateral. So this chapter or this lesson is most very useful for SSV exam and also NMMS, National Means Merit Scholarship exam. So for every state, it will be very useful. It will be very useful. So all of you be ready to understand the quadrilaterals. So before going to start the lesson, so all of you please give me like, one like. So one heart from you. Now let us start. So in this understanding quadrilaterals, first of all we have to understand plane surface and curves, what are the different types of there, and polygons, what are the different types of polygons are there, and angles and quadrilaterals and its properties. So these are the things we have to learn. Now first, plane surface. Plane surface means what? This board is there. So this board is a plane surface. Means what? How can we say? A flat surface which is extending in all directions, in all directions is called plane, or plane surface we can say. So this is a flat surface. So this board is extending in all directions. So this board is extending this direction, this direction, this direction, this direction. So we can say if this board is extending in all directions, then we can say that this board is called plane surface. Plane surface means where x-axis and y-axis are existing, that is called plane surface. For example, generally we are representing plane is like this. So this is a parallelogram, we know very well. So this parallelogram is extending in this direction. So in this direction, in this direction, in this direction. Now we can say that this is a plane surface. Means whatever the drawings, whatever the things we are doing, that is in plane only. In mathematics, whatever the things we are doing, that should be done in plane only. So if you draw a line, if you draw an angle, if you draw a quadrilateral, if you draw a curve, if you draw anything, you have to draw in plane only. So that's what we are using board. So we are explaining board. On the board only we are explaining. So this is called plane surface. So on the plane surface only we can explain anything. On a solid surface we can't express. We can't do anything. For example, solid surface I am taking. So solid surface means which we can hold with our hand. So I'm holding something. So solid. So I'm writing here. So I'm writing here means you can't see what I'm writing because I'm writing from my side. So if you are there, you can't understand what I'm writing. You can't see. If I write there, so those people who are here, those can't see, those can't understand. So that's what we can't do. We can't take solid surfaces. We will take only plane surface. So this is about plane. Next, curve. What is curve? A smooth line or a smooth figure, a smooth path, a smooth figure. See, I am drawing smoothly. I am drawing like this. I'm drawing like this. A smooth line or a smooth figure can be drawn, is called curve, A smooth line or a smooth figure can be drawn is called figure. So if I am drawing a smooth line or a smooth figure, that is curve. Simply you can say curve. So a line is also a curve. So a smooth figure or a smooth drawn which are turning or bending are called curve. So I am drawing a smooth diagram, a smooth figure, or smooth line. So which are bending or turning somewhere, that is called open curve. So that is called curve. That is called curve. For example, see here I am drawing like this. This is going like this. This is going like this. This is going like this. This is a curve. So curve means not having line segments, you don't think. So if your line segments is also there, that is also curve. This is also curve. This is a straight line curve or line curve, we can say. So I am drawing like this. This is also curve. This is also curve. So a curve is nothing but a diagram or a figure, a drawn thing or a line which is bending or which is turning somewhere. So that is called curve. Now types. So what are the types are there? See here, there are open curve is there. Open curve. Closed curve. Simple curve. Simple closed curve. Now we will see one by one. Open curve. Open curve means the curve which is do not having starting and ending points are same. So the curves which do not have same starting and ending point, those are called open curve because the curves are opened. Now let us see here. So I am drawing, this is starting point and this is ending point. Now I am drawing like this. See, this curve is not having starting and ending point same. So it is open. So this is also open curve. This is also open curve. So still now what have drawn, each and everything is open curve only. See here. So starting point, ending point, not same. 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 So open curve means there is a possibility to escape from it. For example, a small mouse, I am keeping one curve. Here I am keeping. So it will come outside. If I keep here, it will come outside. Now, for example, I am drawing like this. So if I keep a mouse here, or a dog here, or a cat here, then what happened? Definitely, it will coming like this, because it is open curve. So means the curves which do not have same starting point and ending point are called open curve. These are examples of open curve. Next, closed curve. The curves which are having same starting and ending point are called closed curve. Now let us see. See here, I am starting here. Again, I am ending there only. So I am starting here. So I am drawing like this. I am drawing like this. I am drawing like this. So where I am starting, there only I am ending. So that is called closed curve. For example, see here, one more thing I will draw. So where I started, here I started. Again, there only I am meeting. So where the starting and ending point are same, those are called closed curve. So if I draw like this also, this is also closed curve. So so I'm starting here, I'm ending. So here overlapping is there, here not there. So here crossing each itself is there, here not there. So both are closure curve. Both are closure curve. Next, simple curve. So simple curve means, see here, open curves are simple curve and closure curves are also simple curve. But that does not cross itself. That does not cross itself. So those are called simple curve. For example, see here. So it is crossing. So where I am drawing here, again it is crossing itself. So it is not a simple curve. It is only curve. It is only curve. So what curve this is? We can say closure curve. Here open. So it is a simply curve only. Okay. We can't say that is open curve or closure curve. This is curve only. Now means crossing is there. Crossing itself is there. See here. Crossing itself means simple curve means there is no crossing itself. There is no crossing itself. So we can say that a curve which is do not cross itself. A curve which is do not cross itself is called simple curve. Whether it is open curve or closure curve. Whether it is open curve or closure curve. For example, in this closure curve, see here, in this closure curve, it is crossing. It is crossing itself. So that's what it is not a simple curve. It is not a simple curve. It's not a simple curve. It's also not a simple curve. So this is simple curve. This is simple curve. This is simple curve. This is also simple curve. This is also simple curve. This is also simple curve. But these two are not simple curve because it is crossing itself. It is crossing itself. So it should not touch again itself. It should not touch again itself. If it is touching itself again, then it is not a simple curve. Then it's not a simple curve. Simple closure curve. So simple closure curve means these are the simple curves. A curve, so which is starting and ending point are same, but which do not cross itself. A curve which is having same starting and ending point. A curve which is having starting and ending point are same and which do not overlap or which do not cross itself. Which do not cross itself. Let us see here. See, I am drawing a triangle. So I am starting here. So again I am coming to that side. There is no cross itself. There is no cross itself. So it is a simple closure curve. It is closure. So that's what it is, simple closure curve. So these are the four types of curves: open curve, closure curve, simple curve, and simple closure curve. I think you have understand each and everything about curves. Now see here, a straight line I am drawing. Straight line is also curve because just now starting itself we have drawn a drawing figure, a figure or drawing or a line which is turning or bending. So which is turning or bending is called curve is here. So straight line also, even though it is a straight line also we can say curve, means line curve, curved line. We can say curved line also we can say. Straight line is also a curve. So now, so plane surfaces we have studied. Now curved surface, curves and types also we have studied. Now we are going to discuss about polygon. So still now curves you have understand. If you understand clearly, so just keep in your comments in the comment section. So now we will discuss about polygons. Now we are going to discuss about polygon. Polygon is also a simple closed curve. So in the place of curve we can say figure. So a simple closed figure which is having only sides, or which is connected by line segments, is called polygon. A simple closure curve, a simple closed figure which is having line segments, or line segments is called polygon. For example, see, this is a closure curve which is having only line segments, is called polygon, So now I am drawing, see here. I am drawing line segments. A simple closure curve I am drawing, which is having only line segments is called polygon. So polygon is nothing but a simple closure figure with sides. Simply you can say a simple closure figure with sides is called polygon. A simple closure figure with sides is called polygon. This is triangle. This is 1, 2, 3, 4, 5. So this is pentagonal. So according to number of the sides or number of the vertices, the polygon is classified, or the polygon has given the name. Now see here, we'll see here. This is triangle because 3 sides are there. This is quadrilateral. Because four sides are there, means a polygon with three sides is called triangle, a polygon with four sides is called quadrilateral, a polygon with five sides, a polygon with five sides is called pentagon or pentagonal, a polygon with six sides, hexagon, a polygon with seven sides, 1 2 3 4 5 6 7, this is a heptagon, a polygon with eight sides, so 1 2 3 4 5 6 7, 1 2 3 4 5 6 7, 1 2 3 4 5 6 7 8. So this is a octagon. If it is having 9 sides means it is a nonagon. If it is having 10 sides means it is decagon. Means a polygon with 3 sides is called triangle, a polygon with 4 sides is called quadrilateral, a polygon with 5 sides is called pentagonal, a polygon with 6 sides is called hexagon, a polygon with 7 sides is called heptagon, a polygon with 8 sides is called octagon, a polygon with 9 sides is called nonagon, a polygon with 10 sides is called decagon. So in our exam, so they may ask anything. So a polygon with eight sides is called what? So you have to write octagon. So if you don't know the name octagon, so you will lose 1 mark. That's what everything you have to learn. Now types. This is classification. These are the not types. These are the classification. Now polygon are two types. So mainly two types. One is convex polygon and concave polygon. Convex polygon and concave polygon. What is convex polygon? What is convex polygon? So a polygon in which, see here, these all polygons are having sides, vertices and angles. Those are called interior angles. A polygon in which each interior angle is less than 180 degrees, then that is called convex polygon. Convex polygon. So if you take any polygon, if each interior angle is less than 180 degrees, then that is called convex polygon. Now see here, this is convex polygon, this is convex polygon, this is also convex polygon, this is also convex. So whatever we have discussed it till now, those are all convex polygon. If you measure each and every angle will be less than 180 degrees. So it is less than 180 degrees. So these are all called convex polygons. Convex polygon. Now we draw another convex polygon. See here, this is the less than 180, this is also 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 less than 180. We can say in another way also, if you take any 2 points in a polygon, and if you join the line segment, the line segment should be interior. So that's a line segment should be interior, then that is also convex polygon. So before going to discuss about what is interior, what is exterior, what is on, so this we'll discuss. Now listen. Now I am taking triangle. So this is a simple closure figure which is having 3 sides. If I take any point inside the triangle, that is called interior region. If I take any point on the triangle, that is called, or boundary of the triangle, that is called on the triangle. If I take any point outside of the triangle, that is called exterior region point. So this is interior region point, this is boundary point, means on the triangle, this is exterior region point. So this total is called interior region, the total outside is called exterior region. Now see here, we are talking about triangle. Now we will discuss about polygon. So this is called interior region of the polygon. This is called exterior region of the point. This is called boundary. So this boundary is called on the polygon. So the points, whatever the points you are taking here, those are the interior region points. What are the points on the polygon you are taking? Those are the on the polygon points. What are the points you are taking outside? Those are called exterior region point. Exterior region point means here we can say that interior polygon interior has boundary and exterior does not have. So only polygon interior only having boundary. The most very important point underline. So the exterior does not have any boundary. Now see, now coming to here. So this is interior angle because inside this is also interior angle, this is also interior angle, this is also interior angle, interior angle. So in this polygon, I am taking 2 points. I am joining these 2 points. I am getting line segment. The line segment must be interior or interior of a polygon. Then that is a convex polygon. Then that is a convex polygon. What about concave polygon? Concave polygon. A polygon in which if one angle is more than 180 degrees, if one angle is more than 180 degrees, then that is called concave polygon. So here, every angle must be less than 180 degrees. Every angle should be less than 180 degrees. So that is called convex polygon. Whereas coming to concave polygon, at least one angle. If one angle is more than 180 degrees, then that is called concave polygon. So for example, I am drawing like this. Now see here, this is a 90 degrees, this is also 90 degrees, so no problem. This is also acute angle, this is also no problem. This is also acute angle, no problem. Now see here, this interior you see here, this much of angle is there. So if you want to find means what, how will you find? So you will find 180 degrees and this small angle and this small angle. Means here one angle is more than 180 degrees, more than 180 degrees. So it is called concave polygon. It is called concave polygon, isn't it? Now another concept we have learned. So joining two points having line segment, that should be interior. Then it is also concave. Then you are saying like this, sir. So no problem. So I am taking here, sir. So line segment. So line segment is the interior of the polygon, sir. So it is also convex polygon, sir. No, you have to check each and every interior part of the polygon, then only we have to say convex polygon. Otherwise we should not say convex polygon. So you are checking like this, 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 you are checking like this. So by checking every region you are concluding it is a convex polygon. If you come to me, I will show you. I am taking one point here, I am taking one point here, I am joining the line segment. Now it is not an interior region, so it is exterior region. It is coming to exterior region of the polygon. It is coming to exterior region of the polygon. So this is not a convex polygon, I will say to you. Understand? Because it is not interior part. This line segment what I have drawn, it's not an interior. So interior means what? So this is everything is interior. This is not interior because the polygon boundary is like this. This is exterior. So that's what. So another classification or another definition of a concave polygon is the line segment if it is not interior of the polygon. So if you take any 2 points in the interior, if you take any 2 points in the interior of the polygon, if you join the line segment, if you draw a line segment, that line segment does not interior of the polygon, that is called concave polygon. That is a concave polygon. So according to convex and concave, again most very important, 2 types are the polygon. Again 2 types. That is regular polygon. Regular polygon. So what is regular? What is irregular? So regular polygon and irregular polygon. What is regular polygon and what is irregular polygon? Let us see. Now see here, I am drawing polygon. So while I am drawing polygon, I am getting vertices. For example, if I take this one, quadrilateral, so I am getting vertices, 2 line segment or 2 sides joining at one point. meeting at one point are called vertices. See here, I am getting 4 vertices, 4 sides, 4 angles. So mainly we can say measurements of polygons is nothing but sides and angles. Vertices are, we can't measure because vertices is a point. Vertices is a point. So that means the measurements of polygon are the parts of the polygon, we can say. Parts of the polygons are sides and angles only. Sides and angles only. Because we can find the angle, we can find the side of a polygon. Now see, these sides and angles. If the sides and angles of a polygon are equal to each other, so means angles are equal to each other and sides are equal to each other, then the polygon is said to be regular polygon. If sides and angles are not equal to each other, then that is called irregular polygon. See here, this is I am drawing a triangle which is all sides are equal looking and all angles are equal. This is regular polygon. So this is here, these sides are different. This is irregular polygon. This is also irregular. So this is also irregular. This is also irregular. So this is looking like regular, but these sides are different. This is also irregular. So regular means all sides are equal, all angles are equal. For our convenience, we know very well equilateral triangle, that is called regular polygon because all angles are equal, all sides are equal. Square, if we take square, the square is also regular polygon because all sides are equal and all angles are equal. Irregular polygon means we can say quadrilateral, so pentagon, hexagon, decagon, nonagon, everything will be coming under irregular polygon. If a pentagonal, hexagonal, everything, if you take equal sides and equal angles, then it will be regular polygon. Now, so in this polygon, after polygon, again we have to study diagonal. So diagonal I have to write, I forgot it. So diagonal you have to study. What is diagonal? Now see here. So this is a quadrilateral, means polygon. A closed figure which is having sides is called polygon. This is a quadrilateral. We can say a polygon name is quadrilateral because it is having 4 sides. Now, I want to find diagonal. So this is a side. So A, B, C, D. Now from vertices onwards, I want to draw a diagonal. See here. From A to B, it is a side. From A to B, I have drawn a line segment. It is a side. Now I want to draw A to C. Then what should I call it is? Shall I call it is a side? No. It is a diagonal. It is what? Diagonal. Means the line segments in a polygon drawing 2 vertices other than 2 edges, adjacent vertices is called diagonal. Means a line segment which is drawn in a polygon joining 2 vertices other than 2 adjacent vertices, is called diagonal. Except 2 adjacent vertices. Excepting 2 adjacent vertices, if you draw or if you join any two vertices of a polygon is called diagonal. For example, so this is hexagonal. So I am giving name A, B, C, D, E, F. Now I am drawing AC. This is one diagonal. AD. This is one diagonal. AE. This is one diagonal. So AF is not diagonal. Now A is completed. Now B. So BC is not possible. BD is one diagonal. BE is one diagonal. BF is one diagonal. Now coming to C. So CD is not possible. CE is one diagonal and CF is one diagonal. So like this, I am joining diagonals. So many diagonals are I am getting. Isn't it? Now see here. Using these diagonals, using these diagonals, there is number of diagonals formula is there. Number of diagonals formula is there. That formula you have to remember, that is n into n minus 3 by 2. N into n minus 3 by 2. For example, quadrilateral. So n means number of the sides. N means what? Number of the sides. In the quadrilateral, how many diagonals we got? Only one diagonal. So we'll check. So n value is 4. N value is 4. So 4 into 4 minus 3 by 2. So 4 into 4 minus 3 how much? 1. So 1 by 2. So 2 ones are 2 twos are. So we got two diagonals, but we have drawn only one diagonal. So we can draw like this also. This is also one diagonal. So in the quadrilateral, there are two diagonals. There are two diagonals. Now in hexagon, so in hexagon we have drawn. Let us see how many diagonals will be there. So n into n minus 3 by 2. So 6 into 6 minus 3 by 2. So 6, 2 ones are 2 threes are. So 3 into 6 minus 3 how much? 3. So 3 threes are 9. So total 9 diagonals will be there. See here. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So total 9 diagonals will be there. See. 1, 2, 3. Next 4, 5, 6, 7, 8, 9. So total 9 diagonals are there. So like that, by knowing this formula, by remembering this formula, n into n minus 3 by 2, we can know the number of the sides of a polygon. Today in the grand test, I will give about this number of the diagonals. If the number of the diagonals is giving, then they will ask number of the sides also. Number of the sides also. For example, they will say like this. Reverse also they will give. The number of the diagonals are 6 in a polygon. Then what is the polygon name? The number of the diagonals are 6 in a polygon. Then what is the name of the diagonal? So means what? They have given n into n minus 3 by 2 is equal to, they have given 6. Now how can you write n into n minus 3 is equal to 2 6 are 12. 2 6 are 12. So what we have to do? We have to substitute the options. So now I will substitute 5. So 5 into 5 minus 3, 2. Sorry, 10. Means 5 only will be there. Means 10. So 5 2s are 10. So 5 2s are 10 means n value 5. N value 5 means what? That is a pentagon. So in the pentagon, diagonals are 10. In a quadrilateral, diagonals are 2. In a triangle, no diagonals. Triangle, there is no diagonal because you have to draw two vertices which are not adjacent vertices, then only you will get diagonal. So here if you take any point that the remaining vertices are adjacent only, so we can't draw diagonal in a triangle. So about diagonals, one more important point, the diagonals of a regular polygon or convex polygon, so all are always inside of the polygon. If you take concave polygon, the diagonal, so see here, these are not two adjacent vertices because one more here is there, so it will be outside. So for concave polygon, the diagonal will be outside. One of the diagonal will be outside, or 1 or 2 or 3, whatever it may be. So in the concave polygon, diagonal will be outside. For convex polygon, all diagonals should be inside. All diagonals should be inside of the polygon. So this is about diagonals and everything. So polygons, about polygon, everything. So now polygons and types are completed. Now angles, we have to discuss about angles. So means what are the angles are there, what are the sum of the angles are there, what are the number of the sides, relation between sides and angles, this everything now we are going to discuss now. Let us see angles. Now angles, see here, I am taking triangle. ABC triangle. So this is vertex, this is vertex, this is vertex. So this is a first polygon. We can say in the first polygon, or we can say triangle. So a polygon with the 3 sides is called polygon, is called triangle, isn't it? So in this triangle, what are the parts of the triangle? So everything is having parts. In our human body also having parts. These are the hands, these are the legs, these are the head, this is the head. So everything in university is having parts. Like that, triangle is also having parts. There are 6 parts, 3 angles, 3 sides. So AB, BC, CA sides, angle A, angle B, angle C are angles. So this is one angle, this is one angle, this is one angle. So in the earlier classes, you have studied angle A plus, angle B plus, angle C. How much? How much? So in properties of triangles, if you extend any side, then the angle formed is called exterior angle. So the exterior angle is equal to sum of opposites its interior angle. So means the C is interior angle. So this A plus B is called exterior angle. What? Exterior angle of C, angle C. Now exterior angle, angle C. This is angle C, this is exterior angle. So this total what? This total is straight angle. Straight angle means 180 degrees. Means I got the sum of all interior angle of a triangle. Sum of all interior angles of a triangle is 180 degrees. 180 degrees, isn't it? Now we'll discuss about square. So we know very well. So this is 90 degrees, this is 90 degrees, this is 90 degrees, this is 90 degrees. So sum of the all interior angles of a square is 360 degrees. 90, 90, 90. So 94s are 360 degrees. Then what about pentagon? Then what about hexagon? Then what about heptagon, hexagon, octagon, nonagon, decagon? What about these? Some of the interior angles we have to learn. Now, some of the interior angles. We have to conclude one common point. Then we can find anything easily. So, what is the common point means? Now, from the starting only one vertex, that is A vertex, I am drawing the diagonals. Using vertex A, how many diagonals I am drawing? Only one diagonal. Is there any chance? Using only vertex A, there is no chance. Means how many triangles I got? How many triangles? 2 triangles. Means number of the sides how many? So 4. So 4 minus 2. 4 minus 2. How many triangles? 2 triangles. So one triangle, sum of the angles is how much? 180 degrees. So 4 minus 2 is 2. So 2 into 180 degrees, that is 360 degrees. So like that we can get. That is the common point, a common understanding. So common concept. Now we'll draw pentagonal. One, two, three, four, 5. Okay, now see here. So this is A, this is B, this is C, this is D, this is E. Now using only vertex A, so I can draw AC diagonal, I can draw AD diagonal. So A is not possible. Now see here, how many sides are there? 5. So what I tell, whatever the sides is there, you do only minus 2. Only do minus 2 because 1, 2, 3. Only 3 triangles are there. So only 3 triangles there means only we have to do minus 2. So 5 minus 2 is 3. So sides is 5. So only 3 triangles I am getting. 1, 2, 3. That's what I have to do minus 2. Here, so total sides are 4. Only 2 triangles only I got. So that's what 4 minus 2, 2 triangles. 5 minus 2, 3 triangles into 180 degrees. So 5 minus 2 how much? 3. 3 into 180 degrees, that is 540 degrees. Next, hexagonal. So A, B, C, D, E, F. So AC, AD, AE. See, 1, 2, 3, 4 sides, 4 angles, 4 triangles, sorry, 4 triangles. So 4 into 180 degrees, that is 720 degrees. This 4, how I got? 6 sides minus 2. 6 sides minus 2 into 180. 6 sides minus 2, that is 4. So one triangle total sum is 180 degrees. So 4 into 180, that is 720 degrees. So like that I am getting. So like that if I do, how will I get? N-sided polygon is there. I don't know n value. So that is depending upon number of the sides. N-sided polygon is there. So some of the interior angles I want. Some of the interior angles. Then what I have to do? N minus 2 into 180 degrees. This is called sum of the interior angles of a polygon. This formula is nothing but sum of the interior angles of a polygon. Now see here, this n minus 2 180 degrees you can say if you do 2 into 90 degrees. So 2 bring to this side, then this is also can be written as 2n minus 4 into right angles. So like this also we can say. So 2 into 90 degrees. 90 degrees means right angle, 2 multiply. So 2 into n, 2n, 2 2s are 4. So 2n minus 4 right angles. 2n minus 4 right angles. Like this we can find any polygon. If they are asking a polygon with 15 sides, a polygon with is having 15 sides, then find the sum of the interior angles they will say. So n value 15. So either use this formula or use this formula. So n value 15. 15 minus 2 13. So 13 into 180 degrees, that is 2340 degrees. So 18 is 234. So 2340 degrees. So like that you can find some of the interior angles. Now we will find exterior angles, some of the exterior angles. See here, for example, equilateral triangle I am taking. This is 60 degrees, then it will be 120 degrees. So this is also 60 degrees, this is 120 degrees. This is also 60 degrees, this is 120 degrees. Means 120, 120, 120. So total 360 degrees is there. So for exterior angle, some of the exterior angle is what I got? 360 degrees. In the square I will take. This is 90 degrees, this is 90 degrees, this is 90 degrees, this is 90 degrees. So 90 into 4, that is what I got? 360 degrees. See, the exterior angle in the triangle itself 360 degrees, in the square itself 360 degrees, means sum of the exterior angle of a regular polygon. We can say regular polygon, interior also regular polygon. So regular polygon, that is 360 degrees. If you take any side, anything, so you will get 360 degrees only. That is the common, because the triangle is having, square is having, next pentagon also will have, next hexagonal, octagonal, nonagonal, decagonal. Everything will be having 360 degrees. Means one common point I got, the sum of the exterior angles of a polygon is 360 degrees. 360 degrees. So this is about angles. So diagonal also completed. Now we have only quadrilateral and its properties. So we'll discuss quadrilateral and about that properties. Like this we will complete this lesson. Now we are going to discuss about quadrilateral. Now we will discuss about quadrilateral. Quadrilateral means what? This is a quadrilateral. A polygon with 4 sides. A polygon with 4 sides is called quadrilateral. A simple closed figure which is having 4 sides. Which is having 4 sides is called quadrilateral. Now see here, I am drawing a quadrilateral. A, B, C, D is a quadrilateral. Okay. Quadrilateral is having 4 sides. Quadrilateral is having 4 sides. That is AB, BC, CA, CD and DA. And quadrilaterals are having 4 angles. Angle A, angle B, angle C, angle D. And quadrilaterals are having 2 diagonals, AC and BD. So these are the parts of the quadrilateral. These are the parts of the quadrilateral. So quadrilateral is having 10 parts, 4 sides, 4 angles, 2 diagonals. So 10 parts of the quadrilateral. So the measurements which are can be done for what? Those are called parts of the quadrilateral, parts of the diagram. Now sir, see here, This quadrilateral is again so many types. Let us see here. First one is trapezium. Trapezium, parallelogram, kite. This quadrilateral is, first of all, it is classified into three types. So one is trapezium and parallelogram and kite. So trapezium, parallelogram, kite. So what is trapezium? So trapezium means a quadrilateral in which one pair of opposite sides are parallel. Only one pair. So one pair of opposite sides are parallel. That is called trapezium. A quadrilateral in which one pair of opposite sides are parallel. See, this side and this side, one pair of opposite sides. This is a quadrilateral because it is having four sides. In these four sides, one pair of opposite sides are what? Parallel. So that's what it is called trapezium. So A, B, C, D. One pair of opposite sides are parallel in a quadrilateral, then that is called trapezium. One pair of opposite sides are parallel in a quadrilateral, then that is called trapezium. Now we understand trapezium. Now properties. What are the properties are there? See here. These are parallel lines. This is called transverse line. In lower class we have studied. So if it is transverse, then adjacent angles, sum of adjacent angles how much? 180 degrees. Sum of adjacent angles how much? 180 degrees. Means we can see here angle A plus angle D is 180 degrees. In the same way, angle B plus angle C is 180 degrees. Means sum of the adjacent angles are 180 degrees are adjacent angles of non-parallel sides. These are non-parallel sides or supplementary. Adjacent angles of non-parallel sides. Are supplementary angles. Supplementary angles means what? Sum of two angles is 180 degrees. Then that is called supplementary angle. So these are the most important property in the trapezium. Next, parallelogram. If one side of one pair of quadrilateral are parallel, then that is trapezium. Then if I take two pair of quadrilateral, two pair of sides of a quadrilateral are parallel, then that is called parallelogram. In a quadrilateral, if two pair of opposite sides are parallel to each other, then that is called parallelogram. These are the legs. AD is a leg and BC is a leg. So these are the parallel sides. Now see here. So AB and CD are parallel and AD and BC are parallel. AB and CD are parallel, AD and BC are parallel. So what I'm saying? A quadrilateral in which two pair of opposite sides are parallel, then that is called parallelogram. Now we'll see properties. See, if you look each and everything, this is equal to this one. Means the first property is opposite sides are equal. Now if you clearly observe, this angle is equal to this angle. Opposite angles are equal. In the parallelogram, opposite sides are equal and opposite angles are equal. The next one is diagonals are not equal. So AC is not equal to BD. So we have to see this one. So opposite sides are equal and parallel, and opposite angles are equal and diagonals are not equal. And adjacent angles are, if you take any two adjacent angles, are supplementary. Any two adjacent angles of a parallelogram supplementary. Any two adjacent angles of a parallelogram are supplementary angles. Any two adjacent angles are supplementary angles. These are the most very important. And diagonals are bisecting each other. Diagonals are bisecting. This part is equal to this part and this part is equal to this part. So diagonals are bisecting each other. Bisecting each other. These are the parallelogram. From quadrilateral we are defining. From quadrilateral we are defining parallelogram. So two pair of opposite sides are parallel, then that is called parallelogram. From trapezium also we can define. In a trapezium, the non-parallel sides are parallel. If non-parallel sides are parallel, then that is called parallelogram. Then that is called parallelogram. In trapezium, if non-parallel sides, these are non-parallel sides. If those are parallel, then that is called parallelogram. Then that is called parallel. How, sir? See, this is a non-parallel sides. I am making this side like this, like this, like this, like this. Now see, this side and this side are parallel. Now it's looking like parallelogram, isn't it? Next, kite. A quadrilateral in which two pair of adjacent sides are equal. Two pair of adjacent sides are equal. See here, AB is equal to AD and BC is equal to CD. In a quadrilateral, if two pair of adjacent sides are equal, then that is called kite. Then that is called kite. We are so flying the kite. In a quadrilateral, if two pair of, this is one pair and this is one pair, two pair of adjacent sides, this is adjacent side. Adjacent means what? So side by side. Side by side sides are called adjacent side. Two pair of adjacent sides are equal, then that is called kite. Then that is called kite. So what are the kite properties? So two adjacent sides are equal, means AB is equal to AD. Diagonals are perpendicularly bisecting. Diagonals are perpendicular to each other. So diagonals are perpendicular to each other. Next, main diagonal, opposite angles are equal. This is the main diagonal. So this main diagonal, opposite angles are equal. Opposite angles are equal. So diagonals are perpendicular to each other. Adjacent sides are equal. So these are the properties of the kite. Now, again see, this parallelogram again is of three types. The first one is rhombus. The second one is rectangle. And the third one is square. Means these three are coming from parallelogram only. Now, before going to discuss about rhombus, rectangle, square, now we will discuss this subtopic. Means again this trapezium is divided into one more. If non-parallel sides are equal, here non-parallel sides are not equal. This is small one, this is big one. If it is equal, so ABCD, in a trapezium, if non-parallel sides are equal, then that is called isosceles trapezium. Isosceles trapezium. This is what? Isosceles trapezium. If non-parallel sides are equal, then that is called isosceles trapezium. In isosceles trapezium, these are the base. So base angles are equal. So that's most important thing. In isosceles trapezium, base angles are equal. Base angles are equal. That's the most important thing. That is the most important point in this isosceles trapezium. Now coming to rhombus, rectangle, square. See here. From quadrilateral to we have got parallelogram. From parallelogram to we are getting rhombus, rectangle, square. Rhombus. First of all, using quadrilateral, we will see. A quadrilateral in which all sides are equal, is called rhombus. All sides are equal means a square also. Na? Then a quadrilateral in which all sides are equal but all angles are not equal. Is called rhombus. All sides are equal but all angles are not equal is called rhombus. A quadrilateral in which all sides are equal, all angles are equal, that is a square. So the difference between square and rhombus. So in the rhombus, all sides are equal, all angles are not equal. In the square, all sides are equal, all angles are not equal. That is. So a quadrilateral in which all angles, all sides are equal is called rhombus. Now, sir, I want to define from parallelogram. See, a parallelogram in which two adjacent sides are equal, any two adjacent sides are equal, that is called rhombus. See, this is a side, adjacent side, these two are adjacent side. So, I am making this adjacent side equal to AD. So, like this. So, I am decreasing. Now, see here what I am getting, all sides are equal, means it's a rhombus. It's a rhombus. A parallelogram in which any two adjacent sides, if one pair of adjacent sides are equal, then that is called rhombus. Then that is called rhombus. Rhombus will be like this. What are the properties is having parallelogram? The same thing rhombus also will satisfy. Rhombus also will satisfy. But extra is all sides are equal. Diagonals are perpendicularly bisecting. Here diagonals are only bisecting. Here diagonals are perpendicularly bisecting. Perpendicularly bisecting. And the angles are also bisecting. Opposite angles are also bisecting. Opposite angles equal and opposite angles are bisecting to each other. Bisecting to each other by diagonals. These are the things. Next, rectangle. Means what? So everything, opposite sides are equal, all sides are equal, opposite angles are equal, all angles are, opposite angles are equal. Next, adjacent angles are supplementary here also, because it is coming from here. So adjacent angles, any two adjacent angles are supplementary, any two adjacent angles are supplementary to each other, isn't it? Next, rectangle from the quadrilateral. A quadrilateral in which opposite sides are equal, all angles are equal, is called rectangle. A quadrilateral in which opposite sides are equal, then here also opposite sides are equal, but all angles are not equal. Here all angles are equal. That is the difference, parallelogram, rectangle. A quadrilateral in which opposite sides are equal and all angles are not equal, then that is called rectangle. Then that is called rectangle. No, sir, I want to define from parallelogram. See here. A parallelogram in which if one angle is 90 degrees, then that is called rectangle. In the parallelogram, if you make one angle is 90 degrees, if you arrange one angle is 90 degrees, then it will become rectangle. How, sir? See here, this angle is like this. Now, this side I'm making straight. Then automatically this side also will make straight. So if I make straight, this also will make straight. So like that it will be forming. So like this it is coming. Means it is rectangle. It is rectangle. So rectangle properties. Here rectangle extra property will be there, that is diagonals are equal. Diagonals are equal. Extra property. Opposite sides are equal. Diagonals are equal. Diagonals are bisecting each other. Diagonals are bisecting. And each angle is 90 degrees. Each angle is 90 degrees. So each angle is right angle. Now, square. A quadrilateral in which all sides are equal, all angles are equal is called square. All sides are equal, all angles are equal. No, sir, I want to define from parallelogram because it is coming from parallelogram. Means we can say like this. A square, a parallelogram in which two adjacent sides are equal, and one angle is 90 degrees. So adjacent angles should be equal. So means like this, and one angle must be 90 degrees. So two conditions, adjacent sides are equal and one angle is 90 degrees. At least one angle is 90 degrees, then that is called square. No, so I want to define from rectangle. From rectangle also we can define. So it is coming from rectangle also. A rectangle in which two adjacent sides are equal, then that is called square. A rectangle in which two adjacent sides are equal, then that's called square. So square is defined from parallelogram, square is defined from quadrilateral, square is defined from rectangle. So rectangle, square, all sides are equal, all angles are equal, diagonals are perpendicularly bisecting. It's a extra point. So perpendicularly bisecting, diagonals are perpendicularly bisecting each other. All sides are equal, all angles are equal, adjacent angles are supplementary angles, opposite angles are equal. All properties will satisfy this square. All properties will be satisfying, so by this square. So these are the quadrilaterals and its types. Now I'll give the bonus concept for you. It is very useful for every exam. For you, very useful. SSV exam, definitely these properties will be coming. So I'm giving the one most very important table. You see that one, definitely you will understand. So what I have explained each and everything, that will be bonus for you. Now let us see important table for us. Now what we have studied quadrilaterals and its properties, that everything will be coming under one table. Let us see. So one by one we will discuss. So trapezium. So trapezium diagram I'll draw here. So A, B, C, D. One pair of opposite sides are parallel. So it's true. It's correct. Two pair of opposite sides are parallel. It's wrong. Only one pair only. Opposite sides are equal. No. Opposite angles are equal. No. Consecutive angles are supplementary. Adjacent angles are supplementary. No. Diagonal bisect. No. All sides are equal. No. Each angle is right angle. No. Diagonals perpendicular. No. Diagonals are equal. No. Means in trapezium only one property, that is one pair of opposite sides are parallel. Coming to parallelogram, we'll draw the diagram. One pair of opposite sides are parallel. Yes. One side parallel only. Two pair of opposite sides are parallel. Yes, this is also correct. If you take one pair of opposite sides, those are parallel. If you take two, those are also parallel. Opposite sides are equal. Yes, AB is equal to CD and AD is equal to BC. Opposite angles are equal. Yes, it's also correct. Consecutive angles are supplementary. Adjacent angles are supplementary. Yes. Diagonals are bisect. So diagonals are bisecting each other. Yes. Next, all sides are equal. It's wrong. Each angle is right angle. It's wrong. Diagonals perpendicular to each other. It's wrong. Diagonals are equal. It's also wrong. So up to here, it is correct. Next, rhombus. So if it is satisfying, so rhombus also opposite pairs equal. Two pair of opposite sides also parallel. Opposite sides are equal. All sides are equal means opposite sides are equal. Opposite angles are equal. Yes. Consecutive sides are supplementary. Yes. Diagonals are bisecting. So in the rhombus, first of all you have to draw the diagram. Yes. Diagonals are bisecting. Diagonals are bisecting. All sides are equal. In the rhombus, all sides are equal. Each angle is right angle. It's wrong. Because in the rhombus, opposite angles are equal. Each angle is not right angle. Diagonals are perpendicular. Yes. Diagonals are equal. Wrong. Because, so this is a big one, this is a small one. So if you draw the actual rhombus, so this is a big diagonal, this is a small diagonal. So a rectangle. So if you draw a rectangle, you can understand what we have to discuss. So A, B, C, D. So in the rectangle, one pair of opposite sides are equal. Yes, because these are parallel. Two pair of opposite sides are parallel. Yes, this is also correct. Opposite sides are equal. Yes, opposite sides are equal. Opposite angles are equal. Yes, all are 90 degrees. Opposite angles are obviously equal. Consecutive angles are supplementary. Adjacent angles are supplementary. Yes, 180 degrees. Diagonals bisect. Yes, diagonals are bisecting each other. All sides are equal. No. In the rectangle, no, all sides are equal. Only opposite sides are equal. Each angle is right angle. Yes, each angle is right angle. Diagonals perpendicular. No. Diagonals will never perpendicular. Diagonals are equal. But yes, from here onwards, diagonals are equal. From here onwards, diagonals are equal. And at last, square. So, A, B, C, D. One pair of opposite sides are parallel. Yes. In the square, all will be satisfied. Everything will be satisfied. Two pair of opposite sides are parallel. Yes. Opposite sides are equal. Yes. All sides are equal means opposite sides are also equal. Opposite angles are equal. All angles are equal means opposite angles are also equal. Adjacent sides are supplementary. Yes, it is also correct. Adjacent sides are equal. Diagonals bisecting each other. Yes, diagonals are bisecting each other. All sides are equal. Yes, all sides are equal. Each angle is right angle. Yes. Diagonal perpendicular, yes. Diagonals are equal, yes. So coming to everything, square only satisfies every property. Square is satisfying every property. Means square is the king of this all quadrilaterals. So square knows everything like me. I also know everything. So something I don't know, but everything I know. So like that, square is there, so you also should be like square. So square should be like you and you should be like square. So I think, so this understanding quadrilaterals, you understand, I think. So all of you understand the quadrilaterals concept. So how many of you understand? Keep in the comment section. How is the today class? Also keep in the comment section. Excellent, marvelous, super, mind-blowing. Like that comments you keep, or what are the feelings you have, that keep in the comment section. So I think you have understand. And also I'm going to give the grand test about this concept, top 10 bits, using the logics and so techniques I will give you. Please write the grand test before 12 a.m. Then after that submit. I will give the all India ranks for you. So then you will come to know where are you in the India. So that's what. So this is today class. If you like this video, just like it. If you want to share any doubts or asking any doubts, so please keep in the comment section. And if you are the new student to my channel, please subscribe my channel, and please share this video. Please share this video to all your friends. Thank you very much. Bye bye.
If you enjoyed this video, please like, subscribe, and share it.